Hi everyone, my name is Amitesh and in this video we're going to master dividing complex numbers. So this is a topic that's confusing for you. Watch till the end. We're going to go it step by step. I'll teach you the secret tricks and in the end we'll get the general formula. And once you can derive the general formula for any number over any number, you'll be able to do any example as well. But let's go through the examples first and dive right into it. So number one is, what is the step-by-step process to divide two complex numbers? Now the first thing to keep in mind is we want to write this expression as some number plus something times I. Okay, so here we don't have that form. We have something plus something times I divided by something plus something times I. So the secret trick to actually achieve this is to make the denominator a real number. Okay, so what that does is then you can sort of, instead of dividing with an I involved, you just get something plus something I. How do we make the denominator a real number? This is a secret trick called multiplying by the conjugate. Okay, so what that means is the following. If you have a number like 5 minus 6i and you multiply with 5 plus 6i, you can use the difference of squares formula. Okay, so the difference of squares formula tells you what a minus b times a plus b is. It's a minus b times a plus b is equal to a squared minus b squared. Now the idea behind this is that we know one thing about it. I is something which squares to be negative 1. Okay, I is the square root of negative 1. Now because we know that I is the square root of negative 1, we can sort of get rid of it or simplify it by multiplying it with itself, or or squaring it in other words. Okay, so that's where we get the idea of multiplying by the conjugate, that we start with this and multiply with the conjugate where we flip the negative sign to a plus sign. We can apply the difference of squares formula. So effectively we're going to be squaring 5 and squaring 6i, and the I is going to go away when we do that. Okay, so what that's going to do, so let's actually work this out. So here we have a and b, a and b. Okay, so a is equal to 5 and in this example, and b is equal to 6i. Okay, so in this specific example we have these two, and now what we can do is we can just write it out as a squared minus b squared, which is going to be 5 squared minus b squared. Okay, so I'm going to write this out here, minus 6i squared, which is going to be b squared. Okay. Now it's very important that when you do this, you need to square the whole of 6i. Okay, so what is 6i squared? It's going to be 6 squared times I squared. Okay, so we're going to get 25 minus of 6 squared times I squared, which is 36i squared, which I'm doing in 2 steps. I squared is negative 1, so we're going to get 25 plus 36, which is going to equal to 61. Okay, so that's going to be the answer to that. It's going to be 61. And you see, by multiplying 5 minus 6i times 5 plus 6i, we've got a real number. And so if we take that expression, here's a philosophy. If we take that expression and multiply bottom and top, we're dividing by a real number. And if you are just dividing by a real number, say you're dividing by 5, you just get 2 over 5 plus 3 over 5i, right? So everything's easy. So we need to divide by a real number. We need to multiply top and bottom by the conjugate. So let's do that. So we've got 61 here when you do that. So we take the expression that we have, which is 2 plus 3i divided by 5 minus 6i. Multiply top and bottom by the conjugate, which is change the minus sign to a plus sign. So it's going to be, it's going to be 5 plus 6i on top and 5 plus 6i on bottom. And you want to multiply, you don't forget to multiply on the top, okay? That's really crucial. So you're just going to get 5 plus 6i on top, 5 plus 6i on bottom. Well, you need to multiply the two complex numbers at the top, and multiplication is easier than division. And on the bottom, we know that we're going to get, so we're going to get 2 plus 3i times 5 plus 6i. And on the bottom, we're going to get just 61, which we figured out. Okay, so 61. So now what is the top going to be? So this is just the distributive law for multiplication over addition. So we just have to multiply 2 times 5 plus 2 times 6i plus 3i times 5 plus 3i times 6i. Okay, and it's important to remember that the I squared is going to be negative 1. So we're going to get 10. 3i times 6i is going to be 18i squared, which is negative 18. Okay, so it's going to be 10 minus 18, which is going to be minus 8. And then 2 times 6i is 12i plus 3i times 5 is 15i. So it's going to be minus 8 plus 27i divided by 61, which you can write as minus 8 over 61 plus 27 over 61i. Okay, so that's going to be your division. And you've written it in the form a real number plus a real number times I, which is what you want. And that's going to be the answer to this problem. It's going to be negative 8. So I'm going to do that in red. It's going to be negative 8 over 61 plus 27 over 61i. Very cool. Okay, so this is the idea. We want to multiply To make the bottom real, you need to multiply by the conjugate so you can use the difference of squares formula. That's all you have to remember. Multiply top and bottom by the conjugate and use this formula, which I've kept in red on the right hand side. Why? Because I squared is -1, and so you make a real number when you square I. So that's how we know to use the difference of squares formula. So I'll just keep emphasizing that I is equal to the square root of -1. Now let's do the next example, and I want you to try to do these two before. Pause and watch, okay? So I want you to master it. So once you watch this video, in any homework exam, you can just do it just like that. Gives you a deep understanding of how to do this. So let's do the I times 3 plus I. So I times 3 plus I, it's going to be the same idea. What do we have to multiply top and bottom by? To make the bottom a real number, so then we can write it as something plus something I. Well, it's the same idea we talked about, multiply by the conjugate. So you just flip the positive sign to a negative sign. If it were a negative sign, flip it to a positive sign. Okay, just flip the sign in between the real part and the imaginary part, if you like. So it's going to be 3 minus I divided by 3 minus I. And that's just going to be I times 3 minus I. Use the difference of squares formula. A plus b times a minus b is a squared minus b squared. It's going to be 9 minus I squared. 3 squared minus I squared. Okay, let's write that out in 2 steps. 3 squared minus I squared, which is going to equal to, the top is going to be a little easier. It's 3i minus I squared. So this sometimes can be just tricky. Minus I squared is 1 because I squared is -1. So it's going to be 3i plus 1, right, divided by 9. Minus I squared is again plus 1. So 9 plus 1, which is going to equal to 10. So we're going to get, you can write this out as, so this is going to be 1 plus 3i over 10, which you can write out as 1 over 10 plus 3 over 10i. And that's going to be your final answer. So let's write that out. And we're going to get 1 over 10 plus 3 over 10i. Now, there is a general trick you can know, which, it's important. I haven't mentioned it yet, but I'll mention it in the last step, which is important to just mentally do it so you don't have to repeat the derivation each time. But I encourage you to practice with it anyway, of doing the difference of squares formula. But when you multiply a complex number by its conjugate, you get its modulus squared. Okay, so this is very crucial because it's a quick way of actually solving it without going through the process. Okay, so we're going to see it in this case. We have a plus ib by c plus di. And what you can do is, if you multiply by the conjugate of the bottom, right? What is the conjugate of c plus di? C plus di, if you multiply with the conjugate, you just subtract c minus di. Change the plus sign to a minus sign. What you're going to get by the difference of squares formula is c squared minus di squared, which is just going to equal to the d squared times I squared. I squared is -1, so minus of -1 is +1. So this minus sign becomes a +1. So you're going to get c squared plus d squared, which is also known as the complex modulus c plus di squared. Okay, the complex modulus c plus di, if you sort of draw out the complex plane, and if you sort of plot out the complex number, so I'm going to sort of do this here. Let's say this is c, this is d. C plus di is going to be this point here. The Pythagorean theorem tells us its distance to the origin, which is 0, 0, is just going to be equal to the square root of c squared plus d squared. Because here you have a right triangle where the base is c and the height is d. So the distance from that number to 0, which is what is called the modulus, which is also denoted by the same sign as the absolute value, is going to be the square root of c squared plus d squared. So if you square that, you're going to get c squared plus d squared. Okay, so that's another quick introduction to the modulus if you haven't seen it. But just to kind of explain, it's a crucial property of complex numbers. It's going to just be z times z conjugate is the modulus of z squared. Okay, I did that again like that. Okay, now that's going to be the formula that's worth remembering. And now what we can do is, using that formula, we can solve and get a general formula for dividing complex numbers. Now, in practice, it's a weird thing in math that happens quite a bit actually, especially when I teach math, I kind of think about this. Using the formula is harder than actually deriving it directly. So in a simple example, you'd rather just go through directly, but certain mental shortcuts help. So here, if you have like a plus bi divided by c plus di, and you multiply top and bottom by c minus di, which is the conjugate, so we know this shortcut. You know that z times z conjugate is modulus z squared. So you can just write off, say that that's c squared plus d squared down bottom. And so now you're just going to get a plus bi times c minus di, which you can work out. So it's a plus bi times c minus di divided by c squared plus d squared. It's not c squared minus d squared, okay, because the I squared is -1. So that's like the difference of squares formula to keep in mind. But then we have that. So you can just write that out. I'll do that in red. It's going to be AC minus ADI plus BCI minus BDI squared. Okay, minus BDI squared divided by C squared plus D squared. So you collect real and imaginary parts. So you're going to get an AC BDI squared is what? It's negative BD. Because I squared is -1, so it's going to be a negative of a negative, which is a positive. So we're just going to get AC plus BD plus I times BC minus AD. Okay, divided by A squared plus B squared, or sorry, C squared plus D squared. And that's going to be the answer for the division. It's going to be that. And we can sort of write that out as one kind of nice fraction, something plus something I. It's going to be AC plus BD divided by C squared plus D squared plus, so BC minus AD divided by C squared plus D squared I. Okay, so that's going to be the answer. As I said, remembering this formula is kind of harder than actually just deriving it in a specific example. But if you can master this, it just helps you to practice along with these examples. So I hope you love that. Subscribe, like. I have infinite math content at all levels, all different levels of math, free accessible math education. There's stuff on my channel that may be more advanced than what you're learning, more basic than what you're learning. But either way, I hope that by subscribing to my channel, you'll constantly elevate yourself to higher levels in your mathematical thinking. You'll constantly be exposed to new math content, and that's going to help you. Even if you're just focused on your math class, if you're really strong at math, you have a leg up on other people, because math comes up in all kinds of life, and being smart in math helps you just be smart in general. So my goal is to just really help change lives through math education. It's a fundamental science, and it's a different kind of thinking that many people don't do. And so if you want to support my vision of doing so, of changing lives, please like and subscribe to my channel, share with friends and family, and I'm super excited to see you in the next video. I wish you all the best. Please take care.